The James Webb Telescope has essentially revealed the clearest image of Proxima B in history, uncovering stunning discoveries about this possibly habitable exoplanet. It coaxes us as we set out on an excursion through space to uncover the hidden mysteries of Proxima B and decide whether it could be the next Earth. We set off into the vast expanse of space, where a mysterious planet exists in the habitable zone of its star, Proxima Centauri. This planet is no ordinary rock. It's Earth's infinite cousin. Proxima B, found 4.2 light-years away, it is shrouded in secrecy and wonder. Could it one day be another Earth, with seas and life flourishing across its surface? But wait, there's more. Proxima B isn't alone in orbit around the red dwarf star. It has a companion, Proxima Centauri C, which could reveal even more secrets. Perhaps there is another companion yet to be discovered. The mystery deepens. Proxima Centauri emits a similar amount of energy to what Earth receives from the Sun. Could this mean there's water on its surface? Might life, as we know it, exist beyond our solar system? As we venture further into space, we encounter an entirely new world of exoplanets, planets that orbit stars other than our Sun. With 200 billion stars in the Milky Way galaxy alone, the incredible opportunities for finding exoplanets are endless. Some, indeed, even wander through space untethered to any star like rogue pioneers. Among them, Proxima Centauri B stands out as a truly exceptional and fascinating planet. With a year lasting only 11.2 Earth days, its proximity to its star is much closer than Earth's distance from the Sun. This means one side of the planet is constantly bathed in light, while the other remains in eternal darkness. Now, let's explore Proxima Centauri, the star around which Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes Alpha Centauri A and B, two G-type and K-type stars that appear as one in the constellation Centaurus. Together, they are the third brightest stars in our night sky. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf or M-type star found 4.24 light-years from the other two stars, making it the nearest star to our solar system. The name Proxima Centauri means the closest star in Latin. It was discovered in 1915 by Scottish astronomer Robert Thorburn. Despite being the nearest star to us, Proxima Centauri remains invisible to the naked eye due to its apparent magnitude of 11.13, far beyond the limits of human vision. However, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarf stars like Proxima Centauri are among the most efficient energy producers. While they may not emit much light, the convection processes in their cores keep them shining for trillions of years. In fact, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf like Proxima Centauri is still debated. For one, it's a flare star, undergoing regular and erratic bursts of radiation. As a low-mass star, its habitable zone is much closer than the Sun's, probably between 0.23 and 54 cents. Yet even this zone may not be as hospitable as it appears. Proxima B may not have a stable atmosphere, which is crucial for maintaining conditions favorable to liquid water. Without this stability, life would be vulnerable to space weather, making it incredibly difficult for life to thrive. So, while Proxima B may appear Earth-like on the surface, it's far from being able to support life. Still, many researchers remain hopeful. One tool that has captured astronomers' attention is the James Webb Telescope. After several delays, the telescope was finally launched in 2018 and is poised to help determine whether there is life on Proxima B. However, as with everything in science, things are never as straightforward as they seem. Some adjustments were necessary to ensure the James Webb Telescope could deliver accurate images, as Avi Loeb, a theoretical physicist at Harvard, explains. If a planet like Proxima B absorbs light from its star, it can also re-emit that light as infrared radiation. The James Webb Telescope was specifically designed to detect infrared light, allowing it to capture images of this radiation from the planet's surface and look for patterns that could confirm the presence of water or an atmosphere. But what if the planet's atmosphere is unsuitable for life? The mere presence of an atmosphere doesn't guarantee life, warns Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere much denser than Earth's, leading to extreme heat that would make life impossible. The mission to uncover the truth about Proxima B is not without its challenges. While the James Webb Telescope offers promise, there are many factors to consider. With mounting costs, space researchers feel the pressure to find ways to study planets like Proxima B. Much is at stake, but the rewards are even greater. The chance to explore the unknown and uncover the secrets of a planet that could harbor life. Could we even travel to Proxima B? It's the closest exoplanet to us, which makes it exciting. It's almost like exploring our own backyard. Even more fascinating is that it's nearly the same size as Earth. Its position in the habitable zone suggests it could indeed have conditions favorable to life. For us, Proxima B's proximity also makes it an ideal target in our search for life beyond Earth. At 4.2 light-years away, it's a prime candidate for interstellar missions. Now consider the feasibility of exploring this Earth-like exoplanet. While we can't go there right now, it's certainly on the radar for future missions. As technology advances, such expeditions may become more accessible. Reaching Proxima B is no simple task. It would take 75,000 years for spacecraft like Explorer 2 to reach the Proxima Centauri system. However, a proposal involving solar sails, ultra-thin sails that could be used to accelerate a spacecraft to the Alpha Centauri system, has been made. This technology uses solar pressure to keep the spacecraft on course, eliminating the issue of running out of fuel. With potential speeds of 10 to 20% the speed of light, the journey to the Alpha Centauri system could be reduced to just 20 years. The discovery of Proxima B has reignited humanity's interest in space exploration. It has provided us with a renewed sense of wonder and possibility, a feeling of hope that we are following in the footsteps of great explorers in the universe. The James Webb Telescope is a marvel of modern technology, capable of taking us back to the earliest stages of the universe. The James Webb Telescope holds the potential to reveal even more about the distant worlds that orbit stars beyond our own. Its powerful instruments could provide insights into the atmospheres, compositions, and potential habitability of exoplanets like Proxima B. As humanity continues to push the boundaries of space exploration, the quest to uncover the mysteries of Proxima B and other exoplanets is just beginning. In the future, missions like the James Webb Telescope studies of Proxima B could inspire new technologies and collaborations. With each discovery, we move closer to understanding whether life truly exists elsewhere in the cosmos. Though Proxima B's habitability remains uncertain, its discovery has ignited a spark of hope and excitement for what lies beyond our solar system. The possibility of finding another Earth-like planet, perhaps one capable of supporting life, remains one of the greatest scientific challenges and aspirations of our time. As we venture further into the universe, the search for exoplanets and the study of their environments will continue to shape the future of space exploration. Proxima B, along with other planets in the habitable zone, represents a tantalizing target for future generations of astronomers, scientists, and explorers. The dream of reaching these distant worlds and unlocking their secrets is one that could define humanity's place in the universe for centuries to come. With each step forward, we uncover more about the cosmos, and perhaps more about ourselves. Mark of the universe, 13.7 billion years back. This is the meticulously safeguarded secret. The farther an item is, the longer it takes for light to contact us. This implies the James Webb Telescope can notice objects in the universe farther away than any other telescope before it. Besides, it can identify these objects in longer infrared frequencies of light, permitting us to see more far-off stars with greater clarity than ever before. Also, here's something considerably cooler. This phenomenal development can give insight into the possibility of life on other planets, like Proxima B. However, like with everything, there are some prominent limitations. The presence of an atmosphere doesn't necessarily ensure life. Proxima B could be like Venus, with a thick, unwelcoming atmosphere. However, get this. The James Webb Telescope can detect such circumstances if they release only 5% of the planet's dayside brightness. While 5% might not seem like much, it's significant when dealing with a star that is generally dimmer than our Sun. If Proxima B has intelligent life, they may be using brilliant orbital mirrors to reflect sunlight from the day side of the planet to the night side. How cool is that? There are innumerable exoplanets ready to be found in our universe. These planets come in all shapes and sizes, with some being tremendous gas monsters, while others look like our own Earth. One kind of exoplanet that has caught the eye of space scientists is the gas giant. These planets are similar in structure to Jupiter and Saturn, but are much larger. Some of these behemoths have been named super Jupiters, outperforming even the biggest planet in our solar system. Anyway, that's not all. There are also hot Jupiters, gas giants that orbit incredibly close to their host star. They exist in a burning climate with temperatures high enough to melt metal. Imagine being able to observe such a planet up close, with its furious storms and extreme heat. In addition to gas giants, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are hot Neptunes, Noon, and mini Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are frequently shrouded in mystery, making their atmospheres difficult to study from a distance. We shouldn't ignore Earth-like exoplanets either, those that resemble our own Earth. These planets come in different sizes, from smaller than Earth to twice its size. There are also super-Earths, which have masses greater than 2 times that of our planet, but are lighter than Neptune. One of the most fascinating exoplanets found recently is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth, with a rocky mass around 1.3 times that of Earth. Despite being close to its host star, it is still far enough away to be considered within the habitable zone. Proxima Centauri b isn't alone. It has a companion, Proxima Centauri c, which orbits farther from the star. This planet has an orbital period of around 5 Earth years and was discovered in 2020 using recovered Hubble data. What's even more captivating about Proxima Centauri c is that it appears to be an exceptionally bright world, possibly due to the presence of a ring system. However, more discoveries still need to be made in the Proxima Centauri system. In 2019, astronomers noticed a change in the star's rotational rate, which could be the result of another planetary companion. If confirmed, this planet would be called Proxima Centauri d and would be roughly the size of Mercury or Mars. Imagine a reality where the night sky is filled not only with stars, but with countless other planets, each with its unique qualities and orbits. The universe is full of surprises, and exoplanets are just one of them. With new discoveries being made continuously, it's an exciting time to be a space scientist. While we don't yet have an exact count of exoplanets, we know they exist in abundance throughout the universe. Exoplanets aren't easily recognizable. It takes cutting-edge technology and powerful telescopes to detect them. These planets are often hidden by the brightness of their host stars, making them challenging to study. However, with advancements in technology, direct imaging of exoplanets is now possible. For an exoplanet to be directly imaged, it must be large enough to be visible to the telescope, far enough from its host star to avoid being obscured by its brightness, and young enough to be hot and discernible from Earth. These requirements limit the number of exoplanets that can currently be imaged, but they offer an intriguing look into the properties and development of these distant worlds. Exoplanets are typically found through the effects they have on their host stars. The gravitational pull of an exoplanet can cause its star to wobble, and this change in the star's motion can be detected by astronomers. The Kepler Space Telescope used the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. This technique has provided an abundance of data about exoplanets, including their size, distance, and temperature. Here are a couple of interesting facts. Did you know that more than 22% of Sun-like stars have Earth-sized planets in their habitable zones? Or that TRAPPIST-1 is home to 7 rocky exoplanets with water on their surfaces? Exoplanets in our solar system can also have natural satellites known as exomoons. With more than 4,000 exoplanets discovered so far, we know they exist in abundance throughout the universe. Hot Jupiters, with their immense size and rapid rotation, are the easiest to detect, but there are countless other exoplanets waiting to be discovered. NASA's James Webb Space Telescope is revealing the secrets of the universe, one discovery at a time. The telescope has been gathering data and capturing stunning images of the universe, uncovering previously unknown wonders. Recently, it made a groundbreaking discovery that will forever change our understanding of the universe. But that's not all. The James Webb Space Telescope has been busy capturing stunning images of star systems and dust clouds swirling and crashing into one another. These discoveries continue to pour in as a global community of space scientists uses the telescope to compile a detailed inventory of the coldest ice ever observed in a molecular cloud. They identified frozen versions of various molecules, including carbon disulfide, ammonia, methane, and several common organic molecules like methanol and water. The James Webb Space Telescope's discoveries are opening up new frontiers in our understanding of the cosmos. These findings will help astronomers unlock mysteries that have puzzled scientists for centuries. As the telescope continues to observe distant stars, galaxies, and exoplanets, it is laying the groundwork for future breakthroughs in space exploration and astrophysics. One of the most exciting aspects of these discoveries is the potential for understanding the conditions necessary for life. As Webb examines the atmospheres of exoplanets, it will help determine whether they have the right conditions, such as water, temperature, and chemical makeup, to support life. This could bring us closer to answering one of humanity's greatest questions. Are we alone in the universe? In addition to studying exoplanets, the James Webb Space Telescope is also shedding light on the origins of the universe. By observing distant galaxies, it can look back in time, helping scientists study the formation of galaxies, stars, and planetary systems. Webb's ability to capture light from the very early universe will help us understand how the universe evolved from the Big Bang to the rich, complex system we see today. As the telescope continues to operate, it is also providing scientists with unprecedented views of phenomena within our own solar system, such as the outer planets and their moons, as well as distant objects like asteroids and comets. By studying these objects, astronomers can learn more about the history and evolution of our solar system, which could provide insights into the potential for life elsewhere. With each new discovery, the James Webb Space Telescope is enhancing our understanding of the universe and pushing the boundaries of space exploration. It is a time of unprecedented excitement in the field of astronomy, and the data it collects will continue to inspire new generations of scientists and space enthusiasts. The journey into the unknown is just beginning, and the answers to many of our deepest questions may lie in the discoveries yet to come.